Hello? All right. So, hello everyone. I am Sonder, and as mentioned before, I work at Weenie. I've been developing for web for about 7 years. Started in Drupal during some Drupal core issues. I've attended some of the Frontend United conferences, been to Bristol, I've been to the one in Ghent before. Maybe a quick show of hands, who has been to a Frontend United before? Okay, who's here for the first time? All right, so I'll hand the mic to you. Oh, I don't have to. You have your own mic.
Hi, so my name is Svetlana, and like I was introduced, I'm a UX designer / front-end developer / those magic unicorns that don't actually exist. And like the introducer said, we are both front-end developers at Weenie. It's a web agency based in Leuven, Belgium. And this is our tagline. Our tagline says, Weenie designs and develops web applications that excel in performance and user experience. And those two things are actually, we're really passionate about. So we're really down to crunching that every byte of a JavaScript file so we can deliver that nirvana to a user, that great user experience that comes with like snappy, performant websites. So we hope whatever we tell today will help you, but will help us as well in the future to make like those snappy and cool performant websites with the latest React features. If you are from Belgium, you might have seen this application before. It's like an election quiz that helps you choose your political party. And this is one of the things that we build with the latest Hooks API. So usually we build big systems, big content websites for our customers. And it's not like we don't jump on the new API immediately. We start with rewriting the code in small components that are not critical. But with this project, we had the advantage of starting from scratch. So, Sander, tell us what we're going to do today.
So this is what our agenda looks like for today. So it's not really design. No, it's code. We're going to look into the latest features of the React API. First, we'll dive into hooks. Hooks are added in the latest versions on React 16.8. You might find some documentation that tells you 16.7, but it got a bit delayed. So if you want to use hooks, use React 16.8. Then we'll talk about lazy and suspense. We're going to do some lazy loading. If you want to use that, it's in React 16.6 and onwards. Then we're going to do a live demo, so really dangerous. And then we'll go over some final takeaways. But first thing we're going to talk about is hooks. What are hooks? Well, just in one sentence, hooks let you use state and other React features, but without writing a class. If you've written code in React before, you're probably familiar with like class components and like functional components. And class components, a basic class component, a class component that extends React.component, and it allows you to have state, and besides from that, you can implement lifecycle methods. So a class component sort of looks like this. You have a class, it extends React.component. It needs to implement a render function and return a React element. We also have functional components, and functional components are basically plain JavaScript functions. So they're plain JavaScript functions, but they can have props. And then again, like with a class component, instead of implementing a render function, you return something, but you also return a React element. And there's a difference, and the syntax is obviously something that's very different. You're implementing a class, bit of OO, or you're doing more of a functional programming, like with the functional components. But two other big differences are obviously a class component has access to state, and a class component can use lifecycle methods. So here to change that are hooks. And hooks, as mentioned before, they allow you to use more of the React features, but without writing a class. So hooks, you can have access to state, you can have access to those lifecycle methods and other React features, but you can just use them in your functional components. They also, hooks allow you to reuse stateful logic, but without changing the component hierarchy. Because if you're doing functional components and you need a lifecycle method or anything, you could maybe solve that using some complex, how do I call that, syntaxes like render props or using higher order components. But they don't really solve the big underlying problem that Reacts need a better way to share stateful logic. And it also allows you, those hooks, they really allow you to split your logic into very, very small functions. So a hook, you can use one of React hooks, you can write your own, but it's the logic and it can be separately tested from your component because it can live somewhere else as well. So it really allows you to split one component into smaller functions. Now hooks, they are completely opt-in. So if you upgrade to the latest version of React, you upgrade to 16.8, you can start using them, but you don't have to. They're completely opt-in. They're 100% backwards compatible, meaning that you can start writing them, your other code, you can use them with class components. So they're available now, as mentioned before, but you can gradually adopt them. There's no need for a big rewrite. If you want to use hooks today, you can just gradually adopt them in your application. There's no need for a big rewrite. So you can take things slow and see where that takes you. So now Svetlana is going to talk about the first hook that we're going to see today called UseState.
Okay, so let's talk about the UseState hook, which is the first hook we'll introduce, and we'll show it by using this example, this very advanced application where we have a counter that starts with a 0 and we have a button. Every time we click the button, the counter goes up by 1. So how would we write it before hooks, before React 16.8? We would write it using a state. So as you see here, we store a state, we store our account in a state, and a state is an object. It always has to be an object in this example. And whenever we want to reference that state, we just use object destructuring and extract it from this.state. And then our button has an onClick handler that calls this.setState, and this.setState again accepts an object where we update count with count plus 1. So that's what you would usually do when you want to use state in a component. A very important thing to remember is that your component, our counter component here, it has to be a class-based component because we had to use classes if we wanted to use stateful logic before. But the thing is, when you're writing your application and you start with small apps or small components, you would usually write it as a functional component because React recommends you to do it. But then requirements change or your client asks for an extra feature. You have to add state to your component. You will have to rewrite your functional component as a class component, and that just doesn't feel right. So we have UseState to the rescue. So as Sander said, hooks allow us to use stateful logic in your function components. And at this point, when you use UseState in your component, you're actually declaring a state variable. A state variable is different than a normal variable as it disappears every time your function exits. But a state variable will be preserved in value. So how do we use this UseState? You see this notation. We have this array actually with 2 elements that is returned by UseState, and UseState accepts just one argument, and that's the initial state. So like in our class-based component, we also said like this state is equal, counter is equal to 0. So that's our initial state, and returns a pair of values. The first element is always the current state, and the second is always the update function. So the current state is like this.state, and the update function is like this.setState. So let's see. Well, opposed to our class example that always expected an object as a state, UseState, you actually can receive anything you want. So we can pass it a number. Like in our example, counter is a number, so we'll pass 0 as initial value. But it can also be a string, it can be a Boolean, it can be an object, and it can even be an array of objects. So you can pass whatever that you want. And as you see here as well, you can declare UseState multiple times in your application. So you can store all multiple values. So let's rewrite our example using hooks. So here we call, let me see my pointer. We call UseState here with the initial value of 0. It returns a count and a setCount function. And then whenever we want to read the value, we just use these curly brackets count. And whenever we want to update, we just call setCount with a new updated value. In this case, it's count plus 1. So this notation is called array destructuring. As we've seen in the class example, we used object destructuring. It's actually like similar. It's also called like syntax sugaring. It will make your code more readable. But the order is always the same. The first element is always the current value, and the second element is always the update function. And these names that you give them, count and setCount, are like up to you. So you can call them like here, like unicorn and a rainbow, but it's better to use like names that you will understand later. So this is the example that we built. We click 5 times and our counter goes up until 5. So what happens in this application actually is every time we click on the button, we call setCount because we want to update our state. But what happens is our entire component, our entire functional component, will be called again. But it will be called with a new value for count that at that point will be equal to 1. So it will cause a re-render. So we have 2 renders. Render the initial render where count was 0, and we have a second render where count is 1. So let's remember that as we move to our second example. This example, we added another button. This button is called a handle alert click button. So when you click on that button, we want to show an alert, and that alert will tell us what the value of count is. But the thing is, we added a timeout. So we want to show the alert 5 seconds after you click the button. So what happens when we click count 5 times, for example, then we click show alert, but before the pop-up shows up, we will click on count another 5 times. So our count should be 10 at that point, and then our alert shows up. What happens? Do you know? What will our alert show? Will it show 5 or 10 or 0 or anything else? Sander, do you know?
Tell me.
Okay, let's look at this example. So we click 5 times, we click show alert, counter is 10, but our alert shows 5. So why is that? The thing when we work with state and hooks in our functional components, we have to change the way we think. So compared to a class-based component, when we use state there, you would expect that the alert would show 10, but in a functional component, that's not the case. Why? Because each render, so every time your functional component gets called again with a new value of count, each render has its own props and state, its own event handlers, its own effects, its own everything actually. So our count, as you have maybe seen in the code, our count is defined as a constant. It's not defined as a variable that changes over time. So, and that's true because inside one render, our count stays the same. So in the first render, it was 0. In the second render, it's 1. So it doesn't matter what when the alert is shown. The alert was triggered when count was 5 at that time. So that alert belongs to the 5th render. Well, no, the 6th render actually. And at that time, it saw the value of count equal to 5. So look at this example again. Every time a function is called in our previous render, it sees the value that was of the render call that defined it. And so every render has its own version of the handle alert click. And that's true for everything, for prop, state, and functions. And that's important to remember when you work with hooks. Okay, so that was the basics of the first hook. Let's move on to the second hook.
So UseEffect. So we've talked about hooks. Now your props update, you can store state now, but we're rendering something, we click a button, so we know that our state is updated, so React is going to call our render function again. But what if we want to do something else, like we want to run a what's called side effect? So we need to do an API call when the component is going to render, or we click a button and we want React to perform something, or what if we want to do a manual DOM mutation? So all of those things are called sides effects. Also things like setting up a subscription. If you know class components, you can kind of think of UseEffect as component did mount, component did update, and component will amount sort of combined. Let me see. And there's two types of effect, really. There's effects that don't require any cleanup. And that is something like the example we'll shortly see, something like manually updating the DOM. So we're going to improve the example from Svetlana a little bit. What we want to do right now is whenever our state updates, so React is going to render it again, props have changed, state has changed, we want to set the document title. So we want access to the document title. We want to do a manual DOM mutation. So whenever you click, we want React to do something. We want to do something after render. So when you think about an effect, UseEffect, you ask React to do something on the initial render and after each sequence render. So after each render, you ask React to do something. So as mentioned before, it's kind of like component did mount and component did update. So if we want to improve our counter, if we were still using class-based components, we'd store our state, we'd have a component did mount. Whenever the components mount, we're going to update a document title. It will be you clicked 0 times because our state is going to be 0. The render function is no longer implemented, but obviously you click the button, states updates, so component did update, the lifecycle method is called, and so we have to change the document title again. So now we have logic in two places. We are writing our logic based on lifecycle methods. We're not really separating our logic based on like a functionality. We have one functionality, but we have code that we have to, we have duplicate code now. We could obviously separate this into a function, but still we have to call it 2 times. So now with hooks, we can rewrite this. And as mentioned before, component did mount and component did update are sort of combined into UseEffect. So now we tell React, whenever after each render, do this. So our component mounts, and after each render, React is going to run the effect. So React will change the document title to you clicked count times. You clicked 0 times. We click the button. So React is going to render this again. And now in our next render, after the render, React will run the effect again. So our document title will be you clicked count times. So this is a very, this is a very classic example. So UseEffect, you ask React to do something after a render and every each update. And what's important is that scheduled effects don't block the browser from pinging. But if I remove the pointer, let's go to here. So I've got a working example here. I need this, like we use effect, it's the working code. So I can open this in a new window. And as you can see, every time I click, React will run the effect. So our document title is now updated. But there are also effects that do require cleanup. Right, Svetlana?
All right. So if you've worked with hooks before, you might have seen this warning. I cannot perform a React state update on an unmounted component. This is a no-op, but it indicates a memory leak in your application. If you've never had this warning before, you're probably better with hooks than I am. But there are different cases where we want to add cleanup in our application. Like Sander said, when we add effects, we are going to subscribe your user to something, or we're going to add events to our DOM. But you want to remove the subscription or remove the events when your component unmounts, so that we avoid memory leaks. And how will we do that in a hook, like a functional component with hooks? We don't need to write a new effect. We don't need to do anything fancy. We just have to return a cleanup function in the same effect, actually. And then React will automatically run this function when it's time for cleanup. But the question is, when is it time for cleanup? So usually in application with class-based components, a cleanup occurs when component unmounts. So did component unmount? Yes, then execute some code. However, as Sander said, effects are executed on every render. So React cleans up effects from the previous render before running effects next time. So if we have an effect that updates every time you click, and we return return a cleanup function, it will also clean up every time we click. So let's look at an example. Here we have a handle click where we update our count by 1, and we have added that click listener in our effect. And we return a cleanup function that removes the effect when it's not needed. Well, this function is called cleanup. You don't have to call it cleanup. It can be like an anonymous function. That doesn't matter. And let's look what happens when we click. When we click 3 times, for example, our cleanup function is called 3 times. This example is not a very good example, obviously. So with event listeners, it might not be a big deal, but when you're handling API subscriptions, you don't want to re-add that subscription every single time we re-render. So we're going to optimize that performance by skipping effects. So how would we skip effects before hooks? You would usually compare your previous state with your current state and component did update. And if anything changed between the 2 renders, if state changed, then you would execute some code, right? Now, because this use case is so built in, how many times did you write that if statement? So the React community added that into the UseEffect API. So I have a technical issue. My ears are too big, I think. So we can actually tell React to skip UseEffect. So to skip the whole block UseEffect that you defined in code, just ignore it in some cases. How do you do that? We pass an optional second argument to our UseEffect. So the first argument was the function that you want to execute. That's our effect. And the second argument is our dependency array. It's an optional argument if you just want to execute that effect every render, so don't pass anything. But if you want to execute the effect only when some values change over time, then you have to add this in your array. So in this example, our effect will be run when counter updates, or when color updates, or when counter and color update. Do you want to run your effect only once? So if you want to like mimic that component did mount effect, you can just pass an empty array. So that would tell React, so listen, there are no values that change over time in my effect. it's safe to execute it just once. Remember to add all of your dependencies, so all the values that change over time in your effect have to be in this array. Because if you don't do that, you will introduce a lot of bugs in your code and you will be searching for them like crazy. So let's recap. There are 3 different ways to use UseEffect. The first is just not passing any arguments at all. That means it will render, it will be called every render. The second will be only called when counter changes value, and the third one will be only called on the first render. Or if you have added a cleanup function, the cleanup function will be called the last render. And let's look at this example. So in this example, I have added 2 states, one state for count and one state for fruit. And what I actually want to do is I want to print count when our count changes, and I want to print fruit when our fruit changes. So I have one button to update count and one button to change my fruit from banana to apple. If I execute this code, this is what happens. So this is our initial render. Our initial render count was 0, fruit was banana. We click one time, we print 1. This is what we want. We wanted to print count, but we also print banana. But that value didn't update, so that's not what we want. And if we keep clicking, our banana keeps getting printed. Then when we click on change fruit to apple, our count that didn't change between renders is printed again. So let's improve our example by adding the second argument count to our first UseEffect and fruit to our second. So now this effect will be only executed when count changes value, and the second effect will be only executed when fruit changes value. So this is what you want to achieve. So the initial render, both are rendered. Yes, that's true. And then every time you change the count, it's printed here. And every time you change the fruit, it's printed alone without the count. Okay, let's move on. So we have another example. In this example, I actually don't have a button. I just want to increment count by 1 every second. So I want my count to go 0, 1, 2, 3, 4. So therefore, I added an effect. That effect sets up an interval that will increment our count, and that interval has like a time value of 1 second, right? And we also return a clear interval. If we exit that function, it will be cleaned up. So what you would expect is that our UseEffect would be executed just once, because we don't want to set interval every time our component re-renders. And we expect that our count will go up from 1, 0, 2, 3, 4, right? Right? Well, that's not the case, actually. Our count will go up until 1. So it will go 0, 1, 1, 1, 1, until infinity. So why is that? Can anyone find the bug in the code? Anyone who's not sleeping? Yes, that's true. So like I said before, every render sees its own values. So when you set up the interval, you set to it that the count is 0, and this effect doesn't have any dependency. So our effect will be executed from our very first render where our count was 0. So we don't update this effect, we don't call it again, because we lied to it, basically. We said that it doesn't have any dependency. So we can rewrite this code by adding the dependency on count. Now, this example is actually not optimal as well, because we will reset the interval every time every second actually, and we don't want that. We just want to call our set interval once, but with the right count value. So we can remove the dependency on count by rewriting this example as like that. And here we've actually used a new type of set count. This that doesn't just expect a new value. You can pass a function to it, and it's called a functional update. So if your new state is computed using the previous state, you can use this method. So the function receives a previous value and returns an updated value. So actually, we don't need a dependency on count in this example because React already knows what the latest value of count was. So this is how we rewrite this example with hooks and with just calling setInterval once. So that was like the basics of UseEffect. Let's move on to our third hook.
Okay, so now for UseRef, I'm going to go over this quickly because we're running short on time. But UseRef is whenever you create a reference, it's commonly used in React to create a reference to actually an element in the DOM. If you create a reference, it returns an object, a mutable object, of which the current value contains the reference. So it's commonly used in React. Let me show you what we're trying to achieve. We have an input field. We have a button that says focus. Whenever we click on the button, we want to have focus on the input field. So we need a reference to that actual DOM node. So using the hooks API, we create a constant. We create a, for example, here we call it nameRef. Let me show you. So we have a nameRef. We call the UseRef hook and we initialize it with null. So at first our nameRef.current will be null, but then we pass an attribute ref and we pass in the nameRef, which is using the UseRef hook. So our nameRef.current, when we click on the handle focus, it will contain the DOM element, the input element. And so whenever we click on the button, we will receive focus on the button. I've got this example working as well. So here we have a text input, a nameRef. So we type something, cool, we have focus. Whenever we click again, we receive the focus. It contains the current, contains the reference to the DOM node. Now hooks are all, we've shown some basic hooks, and these hooks that we showed you, they're all part of React, React core. But you can also write your own hooks, and that is really cool. There's a few things I'd like you, well, this is an example, but so now maybe let's try to create our own hook. So I'm going to create a new sandbox. Using create React app, cool. Wait, oh, this is it, right? Okay, so we're going to create our counter again. And here we have our counter. Let's render our counter. Okay, now as mentioned before, we want to implement a counter. So what we did before was, well, UseState. We import UseState from React, and then here we have a count. We have a way to update our state, and obviously we use array destructuring to UseState. We initialize it, our initial value 0. Cool, so now we print the count, and we should see 0. Cool. Let's wrap it up in a span. And I'm going to add a button. So let's add a button. And I'm going to call it plus, and one that will be called 0. Yeah, that's looks like our logo, but it's not. So now whenever we click on the button, we had an onClick handler. And so onClick, whenever you click on the button, we want to, whenever you click plus, we're going to update our state. So set state, whoa, what's happening? So it's not set state, set count, obviously, and we're going to so say count plus 1. So whenever we click, is that working? Yeah. Now we want the same code on our minus button, but we obviously need the count to go down. Now, as I told you, with hooks, you can reuse logic. So why don't we just create a new file and call it useCounter? we create a use counter. And now let's just duplicate our logic here. So we only need to use state. And so a hook really is just a function. So we can write a function, use counter, just by convention, whenever we write a hook as a use. And we have our counter. And let's say that it has a default value of 0. Now, our counter, it will contain state. And let's say that it returns the count and the set count. Let me check. So use count is not defined. Yep. So now here we import our hook. So we import use counter. Use counter from. So we obviously have to export it. There we are. And maybe it's just relative to, oh, obviously that should be there. Count is not defined. Okay, so now we're going to use our own custom hook. Now we haven't changed all that much, so it will look exactly the same. So we have a const count and set count, but we have our own hook that says use counter. Counter initialized at 0. And this works. But now let's change it. We're going to add 2 functions, increment, return. It will, whenever you call increment, we want to set the count to count plus 1. And then we also have a decrement function. And so we're going to return. Now our own custom hook has changed. So we're going to actually return the increment function and the decrement function. Stop warning. So now we can import the increment and decrement from our own hook. And whenever we click, well, we want to increment. And whenever we click on the minus, we want to decrement. I think I still have some. Okay, and now so we've written our own hook. And now we can share this logic, this own custom hook in our code. We can also share it with the community. And this is obviously a very trivial example. There's a really good way to get started if you want to use hooks. Is this website called usehooks.com. And there's also a great collection of React hooks on GitHub. So it's really nice. It allows you to really share logic and reuse it. Like there's good examples if you want to use like an event listener as well. So I think we have some time left, right? New in React 16.6 was lazy, and it was a function. And React lazy allows you to render a dynamic import as a regular component, something really cool. It's not yet available for server-side rendering, but React lazy allows you to import a component, and React will only load that module whenever it's going to render the component to the screen. So here I have written a very lazy example. So I have one component, it's called lazy example. And using this syntax, so lazy, you pass it in a function. That function must return a dynamic import, which it will return a promise. And then whenever React is going to render the lazy example, obviously in this case, it's going to render it immediately because we have no logic there. But it will include the module, but it will be in a separate bundle. But if we try to run this, React says like, hey, I have to lazy load something, but I don't know what to do in the meantime. So that is why when using lazy, you're also going to use a suspense component. And the suspense component is used to, well, show a loading indicator. So in your app, to fix the error, we wrap our dynamic import or our lazy import with a suspense. And now everything will work. And while the module is loading, we show our fallback, which in this case is just a div that says loading. To quickly show you this, I've got a very simple app. Now we're using lazy. It's commonly used for code splitting, and a really good place to start using code splitting is when you're doing routing. When you have an app that uses routing, when you're on a certain screen, you only want the code for that screen to be loaded, and you can load the rest later. So that's exactly what we're trying to achieve here. We'll basically have two routes. Whenever you navigate to the home, you will only see a navigation. Whenever you go to the /red, we want to lazy load the red component. And whenever you go to /blue, we want to lazy load our blue component. Oh, right. So whenever we go to our main, we see nothing loaded. But whenever we go to, or we see our main bundle being loaded, that contains our navigation. But whenever we click red, our red component is being loaded, and it contains our red component. There's obviously lots of Webpack hot module reloading things. But here, we're only loading what we need when we need it, which is something really useful. Whenever we navigate from the start to /blue, you see that our component blue is also loaded from the start as well. So React is including what it needs. React is loading what it needs, what is currently rendered. That was the GIF for the demo, if things went wrong.
This is what happened.
Well, so some final takeaways. Hooks, they're really awesome because you can use functional components. You don't have to like rewrite things to class if you want to adjust the component just for a little bit. And obviously, I think there's also like functions. I think it's easier to like uglify functions as well. So that is why React is really pushing towards functions as well. It's one of the reasons, I think. And using lazy and suspense, you can really improve your app by just loading what the user needs when the user needs it. So we'd like to say thanks. We hope this was useful. Hooks are, again, they're really awesome. We've used them as well in STEM test, as Svetlana mentioned. We've used them in other projects as well. We've upgraded some of our code bases to the latest versions of React. And as mentioned, we've gradually adopted them in some components. So there's no need for big rewrites. So we really hope that you use them as well. And so thanks. And hopefully you'll write your own hooks and use lazy to only note what the user needs.
Thank you so much. Wonderful. Well, we've got 5 minutes, so we've got some very quick questions. If you want any questions in the room or across the world, Slido them up. So we've got one here. Is it better to split up your code in multiple UseEffect hooks, or only use what? Sorry, shall I start that again? Is it better to split up your code in multiple UseEffect hooks, or only use one big UseEffect function?
These hooks really allow you to split up your logic. So if you're doing it's really better to like split up your code based on like logic. So it's really better to split up into separate use effects. But if they're like, if one is like the example with the counter, if you're also like doing an API call, like do that in a separate effect, like update the DOM, that can be one effect. And then like doing an API call, that is a separate effect. It's doing something completely different, because that is the real benefit of hooks. Because if you're doing that component like did mount, you would have to like update the DOM title and in that same function, like call a separate function or have the logic there that calls an API as well. So here you can really split up. So you can really split up in separate effects. So I would do that, yeah.
That's all on the Slidos. Any questions in the room for the last few minutes? No, apparently you were so concise. Everyone understands perfectly. Wonderful. Thank you so much. Really, really informative. Give it up.